This is Unit 7, Section 7.4. Today we're going to conclude our unit by looking at volume of spheres and then composite figures as well. So again, like I said, excuse me, this is going to finish up our unit. We're ready to review and test after today. So we have talked about the volume of prisms and pyramids and cylinders and cones. Our last object, that's kind of the basic building blocks of all three-dimensional figures, would be a sphere. And so the volume of a sphere is 4/3 pi r cubed. R is the only dimension that we need. So once we have the radius, we can find the entire volume that would fill that sphere. So in this case, we don't have to find the area of the base. We don't have to worry about Pythagorean theorem because there's no side lengths or slants that we can be given here. So it says find the volume of each of the following spheres below, round to the nearest tenth. So as long as I have radius, I should be able to go straight to it. This is going to be 4/3 pi r cubed. This one, 4/3 pi r cubed. And again, I'm just ready to fill that in. 4/3 pi r cubed. Well, no, pi's r cubed. Okay, anyway. It made me laugh in my head. Back of the ranch here. So when we are looking for a radius, if it's given, we can go straight to the problem here and use our calculator to find that volume. So we'll go 4/3 pi. Don't forget pi. People are going to forget that. 7, and then we'll use our caret button here to the third. All right, so again, this is the exact answer, 1,372 pi over 3. I'm going to use my toggle button to get a decimal. So I get 1,436 points. Okay, that 5 is going to bump up the 7 to an 8. So 1,436.8 inches cubed for my total volume. On number 2, again, we're just looking for a radius here. They gave me the diameter. So the only switch we need to do is cut this in half. And so when we take 33 and divide by 2, we'll get 16.5 for our radius. Again, once I have that, I'm ready to go to the calculator. 4/3 and then pi. And now we're going to do r cubed. 16.5 is our radius. And we're going to raise that to the third power. So now we already had a decimal, so it's not going to give us that pi approximation. It's going, or sorry, in terms of pi, it's going to give us our approximation. So this sphere is 18,816.56. The 6 is going to bump it up to 0.6. So my volume is going to be 18,816.6, and our units are centimeters cubed. And number 3 on here, again, we're looking for the radius only is what I need to plug into my formula. And even though it's out to this side, that's still our radius. I could draw it in anywhere inside of here. Out to there, it's going to be the same piece there. All right, so to my calculator, I feel like I say to the back cave, to the calculator, we're going to go 4/3 pi. And then we have 2.8, which was given to us, to the third. Calculator tells us that this is going to have a volume of 91.95. 5 is going to bump that up to 92.0. So our volume will be 92.0. I left space because I almost forgot my units, meters cubed there. So I think I saved the, not necessarily easier, but the least tedious. I saved this formula for the end because what we're going to do next is take what we've just practiced with pyramids, prisms, cones, and cylinders, and now introducing the sphere and put them together to form what we call composite figures. And so a composite figure, it says define the volume of a composite figure, break into basic figures, and then add their volumes together to form the composite volume. And so we don't have to have another formula to find the volume of this figure or another formula to find the volume of this one. What we're going to do is we are going to take what we have here and use our building blocks of cylinder, prism, cone, and sphere. I feel like I forgot one. Cylinder, prism, cone, pyramid, and sphere, and break it into more manageable parts, similar to what we did with the area where we had basic shapes and then we could look at composite shapes. So on the first one here, I'm going to look and I see here kind of a breaking point here where I see a cylinder on top of a cone down here. So if I find the cylinder's volume and then I find separately the cone's volume, if I add those two together, I will get the total volume. So that's our goal, is to find the total volume. All right, so cylinder, this is where we have our volume formula. That is pi radius squared times height. Okay, so do we have a radius? Okay, we have the diameter is 6. So my radius will be 3. The height of my cylinder, okay, again, they gave me the entire height of the object, but just my cylinder, do you see it's cut off at that 8.5? And now I can find the volume. So I'll go to my calculator, and I have pi 3 squared times 8.5. And so here I get 240.3. Now the cone, we're going to do the volume, and we do 1/3 area of the, pi r squared, the area of the base is a circle, times the height of this cone. This same base that we have here, when we drag it down that had a radius of 3, is the same as this base down here. So I'm just going to use that same 3 here. The heights, though, are different. This cylinder is 8.5, and we know the entire object is 12.5. So I need to subtract these two numbers in order to get the height that I have just for my cone. So when I take 12.5 minus 8.5, I get 4. So that's going to be my height of my cone here. On my calculator, I can go 1/3 pi r squared times our height, 4. All right, so again, they gave me the exact answer, 12 pi. I'm going to use my toggle button to get the approximation of 37.699. So I'm going to round that up to 37.7. All right, and my final overall answer, I have the cylinder here and the cone here. The total volume, I'm going to add those two numbers together. 240.3 plus 37.7. To get my overall volume, I didn't have to have a separate formula, a separate new formula. I'm going to combine my cylinder with my cone. And when I combine those, that's where I get about 278, and my units will be inches cubed. All right, so again, this will review the formulas that we'd been using previously while also introducing the composite idea here, where we're going to add two figures together. All right, looking at number 2. Again, we're trying to break into basic figures. So we want to break this big figure into basic figures. So if we look at this, I see, again, kind of a separation here where I'm going to look at a small cylinder versus the large cylinder. But both of these are the same object as far as their shape, but not the same size. All right, so when we're looking at the small cylinder, we have our circle here. All right, we need volume is pi r squared times the height. There are no numbers here on this one. Maybe let's look at this one and see if it can help us out. Pi r squared times the height. Okay, so this one we do know all the way across is 38. So if I cut that in half, I get 19. Okay, so we're rocking and rolling on the large one. We have a height here of 14. So I'm going to go ahead and use my calculator to find the large one since that information was provided. So I'll do pi times 19 squared times 14. And so here I get, again, exact answer, 5,054 pi. I'll go ahead and toggle that to 15,877.6. 15,877.6. Okay, so then back to the small. We still need a radius and a height here, and they didn't give us either one of those. So let's look at what we can figure out. We know that this all the way across is 38. So we'd have to agree that this is 38 as well. They have given us this piece of information that here is 13, but that's not part of my cylinder. And then there's tick marks telling us this piece is 13 as well. So again, if I look all the way across as 38, I know this plus this plus this has to add up to 38. So I'm going to go ahead and take those away and see what we have left over for what the diameter is. So 38 minus 13 minus another 13 is 12. So we know this whole length is 12. Now we have something about that small cylinder. We're having to work a little bit. So if we need a radius here, I'm dividing that in half to get 6 on my radius. I still need times the height here. So again, I was given the 14 here, and anything across from it, there's 14. So what about the distance that's left up here? Notice I have another measurement, the 23. So I'm going to take the 23 and subtract the 14 to see what's left over of the height for my small cylinder, which is 9. All right, so we had to do some work for the small cylinder here, but once I have those two things filled in, I can go to my calculator. So pi r squared times 9, and now I have 324 pi. I'm going to toggle that to get 1017.9. 1017.9. My total volume will equal this value added together to this value. So I'm going to take my small cylinder and add it to the large cylinder to get the total volume for this entire kind of cake-looking object. So my calculator, I have the 1017.9 plus the 15,877.6. Well, that makes sense that this one's so much bigger, it looks bigger. For a total of 16,894, 95.5. 16895.5, and we are measuring that in millimeters cubed. All right, so there's our second composite figure. Break it into more manageable figures and then find the total together. All right, so let's look at two more here. On number 3, all right, we need to take this composite figure and break it into more manageable pieces. So on this one, I don't see cones and cylinders like I did on the other side. I see a pyramid with a triangular base here. And then on bottom, I see 2 bases, so I see a triangular prism. All right, so this is going to review a couple days ago when we were working with these 2 objects. All right, so if we have a triangle base, I need to find the area of that base. So I need to do base times height, and what I do there is the same as this base times height for my pyramid. So I do have 8.8, but I don't know this piece. I have to use the perpendicular corner. I can't use that 13.7. So Pythagorean Theorem to the rescue. We're going to take 8.8 squared plus that unknown height that I need to equal that 13.7 squared? All right, so if I use my calculator, I can get 13.7 squared minus the 8.8 squared. Whoop, 88, that's not right. And I get 110.25. Okay, so I need to square root that because right now I have x squared is equal to that. So x is going to equal square root of 110.25, 10.5. Okay. So now I know this piece here is 10.5, which again we said was the same 8 by 8.8 by 10.5, 8.8 by 10.5. Now I can use this here. 8.8 times 10.5. Oop, that's not a half. There we go. Divided by 2 for the triangle. And then when I have the height of this, okay, so here I need to go from the apex to the center. Okay, so again, I run into an unknown here. So I still need a height here. Let's see, they gave us the 25 all the way from apex. There's our apex all the way down would be 25. Ooh, they did give us this 10. So again, if I put these two together, from apex there to here, those two things are adding up to 25. That helps me find this height is 15 by taking the 25 minus the 10 we already have there. All right, so I think I might have created my line a little bit too close, so I'm going to pull that down so that I can use my calculator and find the volume of that top pyramid. So first for the area of my base, I'm going to do 8.8 times 10.5 all over 2 so that I can have a triangle. So now I get 46.2 here. And pyramid, volume is going to be 1/3 area of the base times height. And so we'll get, again, I'm moving that down a little bit more. Whoop, whoop, whoop. What do we get there? All right, so 1/3. There's our volume formula. Area of the base we calculated. Had to do a little work there. 46.2 times 15. All right, so we get 231 here. Let me double check. 1/3. 46.2 times 15. Yeah, 231. It just looks smaller than what I was thinking. All right, so we get 231 here, and then our prism. The nice thing is that it has the same base. So again, even though we had to do some work to find this, it's the same base for our prism. So I can go directly to that 46.2 already. I don't need to recalculate it again. It's the same base that I had for my pyramid. But the height here, we said this prism is 10. So the volume here, we're going to do area of the base times 10. All right, move that decimal place, we get 462. All right, so overall, total volume, we're going to take our 231 and add it to the 462. So in my calculator, I can add that. I already have 231 pulled up plus the 462, and this is where I'd get 693. And my units, we have meters cubed. And that's really big if that's our meters. All right, so our last one today, looking at our number 4. And so again, we don't have a formula for this specific object. So we break it into more manageable pieces. And so I see what I'm going to call a hemisphere. And I hope we've heard that word before, as far as like the globe has the northern and southern hemispheres. And so that's where we live, in the northern hemisphere. And it's not an entire sphere, it's half of it. Just like we have a semicircle, which is half of a circle. We have a hemisphere, which is half of a sphere. All right, and then on the bottom here, I'm seeing a cylinder because I have two bases here. All right, so I might need more room there, but the nice thing about a hemisphere or a sphere in general, like we just practiced, is we only need a radius, 4/3 pi radius cubed. All right, so diameter was given, but I can divide that by 2 to get 11. All right, so when I look at my calculator, I'm going to do my 4/3, and then I have pi, even though that is a weird looking pi there, and 11 to the third. Okay, so right now I have 5,575.3 with rounding to the nearest tenth. But this would be if I had an entire sphere, because I haven't altered my formula. I did the sphere formula. A hemisphere is half of that. So we want to go ahead and divide by 2. So my hemisphere, I'm going to take what I got for the sphere and divide by 2. And that's why when I look at this, come here, cylinder. Oh boy. I just wanted to pull this down. Wait for me. Just needed some more space here, my friends. All right, so the volume here, and then we'll get to the cylinder. So the volume of our hemisphere is a sphere cut in half. So when we divided by 2, we got 2,787.6. 2,000, I think I already forgot the number, 787.6. All right, so once we find the hemisphere, now we're looking at a cylinder. Cylinder, we need pi r squared times height. All right, so this is the same radius that we had before. We'll still use that 11, and then we need the height from our circle up here to the circle down here. Okay, so be careful. They've given us 45. This is not the height of just the cylinder. That's the height of the whole object. So if we went 22 across, everywhere in here is 11. So we want to be careful here and subtract. 45 minus 11 will leave me with the height of the cylinder, that 34. Now I can go to my calculator to find it. Pi r squared times our height of 34, and 4,114 pi, but I'm going to use my toggle button to approximate this. 12,924.5. 129424. 129424. I don't think that was right. 12924. So I had an extra 4 in there. I'm losing it here. All right. 24 point, what am I rounding to? 0.5. This is going to be my volume for the cylinder. To find the total volume, I need to add this number here to this number here. So I'm going to find my volume to be 2,787.6 plus 12,924.5. 2,787.6 plus 12,924.5. Add those together, we get 15,712.2.1. 15712.1, and we are in feet cubed. All right, so today is some review of pyramids, cones, cylinders, and prisms, but we also introduced sphere, hemisphere, and then putting objects together. We can always break down any larger object into these basic objects. Let me know if you have any questions, and I'm happy to help.